Well, I'm going to be looking at this problem, which is the mixture of two sound sources, Kyle and Stan, let's say, and they're speaking simultaneously. And we've got two microphones, and we want to have an algorithm which will separate them speaking into the two individual speakers. Unfortunately, in real life, it's a little bit more difficult than this because we get reverberations off the walls and the ceiling and so on. And as you can see here, we've got reverberations off the side, so there's more than one path that the speech takes. And this means that we have what's called convolutive mixing, and the mixing process itself in real life can be filters that are quite large. They could be, let's say, 1,000th order. But instead we do a simple simulation of this and take two pure speech signals, and when we mix them through a polynomial matrix, actually we're going to put it through an autoregressive system, but the basic idea is that it goes through some kind of dynamics and it gets mixed together, and then the job is to separate the two again into the individual components. I'm going to use the natural gradient algorithm, which has been around for over a decade, and the natural gradient algorithm's here, and it's quite computationally intense. This is the time domain version, and you'll see that it's not that complicated, but it requires the updating of the individual elements of a polynomial matrix. It also requires nonlinearity depending on the probability distribution of the speech signals. And without more ado, and here we go, here's a mixture of two speech signals, which is just a simulated mixture.
In doing so, he became the founder of modern acoustical engineering. In doing so, he became the founder of modern acoustical engineering.
And each channel is mixed with the other. And we run the program, which is written in LabView. And there's the two signals. And the first thing it does is it works out the probability distributions of each channel, which will pop up in a second. The PDFs, and there they are. And we look in more detail at the ideal versions of these. You can see that it forms this sort of double exponential distribution, which is a Laplace distribution, a little bit different from the normal distribution, which you'll see there in red. So the Laplace distribution is quite common for speech signals, and according to the theory of the natural gradient algorithm, based on that we need the signum function, the signum function as an activation function in our neural network. It's really a neural network that we're updating, even though the algorithm might not actually look like that. So this is used in the program. So the program itself, we're going to use LabView, and as I said before, and if we wait for the signals to come up, and then we'll listen to them, which are the mixtures again individually. Won't be very good at the moment.
In doing so, he became the founder of modern acoustical engineering.
Mabel stood on the rock.
You can see they're both well and truly mixed together. Now the separation is happening now, and I'm skipping ahead because it does take some time. And often with this algorithm, one of the channels often works better than the other. There's one channel, the left-hand channel there is pretty good now, I can tell by looking at it, and the right-hand channel is not bad.
In doing so, he became the founder of modern acoustical engineering. In doing so, he became the founder of modern acoustical engineering.
Just hear the other channel in the background.
Mabel stood on the rock. The auto stopped itself.
There we have it. And
in doing so, he became the founder of modern acoustical engineering.
It'll be perfect now.
Mabel stood on the rock. The auto stopped itself. Mabel stood on the rock. The auto stopped itself.
Barely make out the other channel. Here's the program written in LabView. It's quite complicated because there's quite a lot of loops. Although it's computationally intense, it's not that difficult to program. There's the formula for the natural gradient algorithm, and that's the nonlinearity that we're using, which is just a simple signum function. And that inner loop there is the summation function. LabView, of course, using G code, which is data flow programming.